20 seconds, I think we can get started. So hello everyone, my name is Luis. I'm a computer engineer and operator of OpenStack at CERN. And together I'm with Kuba and Daniel, and we are going to talk about one of the hot topics in our team, that is our migration from Neutron, Neutron from LinuxBridge to OVN. I must say that it's a bit sad of a presentation because it's the last one we will be doing with Daniel, but it's a nice cherry on top of all the work he has been doing for the last 3 years, and a lot of the work that you will see today is thanks to the hard work of Daniel during this time. But before getting into technical details, a bit of context of who we are. Basically, we work at CERN. CERN is the largest particle physics laboratory in the world. It's located in the border between France and Switzerland, and it's run thanks to the collaboration of more than 20 countries. All these countries bring together hundreds, thousands of scientists, engineers, technicians from all around the world to work together to build the next generation of science, to explore what is the universe made of. To do that, we have built a series of particle accelerators that fit the largest one, that is the Large Hadron Collider. This is the LHC. It's a particle accelerator that is 27 kilometers of circumference. It's placed underground around 100 meters. And in this accelerator, we accelerate particles. We make them collide in 4 different experiments, these different ones that you see here, at a rate of around 1 billion times per second. With all the data that is produced by the LHC, all the scientists try to do different areas of research, exploration, to put some more piece into this puzzle of what is the universe made of. And to support this mission, to have all this infrastructure, the IT department in the organization, basically us and many other people, we run a couple of data centers, one that was built in the 70s, and another one that was put in production last year. Both of them, they are managed with OpenStack. We offer to our users the traditional offering of compute, virtual machines, physical machines, containers, different kind of storage based on self, block storage, share objects, and a set of offering around networking, mainly load balancing, and these other things. And both of them in these different 2 regions. OpenStack in our environment is for a vast set of use cases. You will find from analysis tools for scientists, batch computing, GitLab, HR applications, so a bit of everything, and also a bit of different profiles of users. Our user base is quite different. And this has been running in production since 2013, so we can say that OpenStack these days for the organization is a stable, it's a consolidated service, it just works. This doesn't mean that there are areas that we investigate, that we want to develop further, things these days around heterogeneous computing, scarce resource of our resources, how to manage that, how to do maybe reservations. And there is an area that is more connected to what we are talking today now, that is that we want to modernize our networking capabilities. Because over time, our cloud networking has evolved with OpenStack. We started back in the day with Nova Network. At some point, we adopted Neutron. They were running in parallel for quite some time, until we finally deprecated Nova Network. The same year we were done with the work, there was an announcement of the deprecation of LinuxBridge, so continuing with this work. But the common thing around this time is like our offering has been rather basic. Since day 0, we have been using LinuxBridge. We never offer to our users advanced features, anything like floating IPs, NAN, or terminal networks. We tried at the beginning security groups, some performance issue, we never offered them. And I'm saying all of this to put a bit of context of our migration. This is our landscape. We have a very basic setup. So basic that, in principle, our network looks like a little bit like this. So basically, we have a data center network, highly segmented, very different segments. Everything is exposed to our end users as a public, flat, routed network with all these segments represented there. So all of this to say that for many years we have regretted to have so little advanced offering for our users, but in this case, in the context of this migration, has been a blessing because it's obviously a simple setup that in the complexity of things help a little bit. So yeah, so in 2022 we have the announcement of the deprecations of LinuxBridge, and we started to take a look. We took a look to the alternatives, to OBS, OVN, and yeah, we went for OVN as a more future-proof driver, also the one that the Neutron developers as well were a bit promoting more to become the default. And this as well to pave the way to start offering these more advanced features that for all this decade we have not been able to expose to them. And it was a perfect timing with our new data center. As I told you, we have two, one from the 70s and another one put in production in 2024. So this one was a greenfield deployment, different OpenStack region. So I said, let's go for OVN from the beginning, so no need to migrate anything. We also gained operational experience with it, and this is what we did, and we opened to our users in 2024 in products. But before that, because we also had to migrate the existing data center that was there to OVN, we decided to do some scalability tests. So let's do some tests to see if the scale we have in the other one, our setup of OVN, will behave more or less okay, get some confidence with our decisions. So this is what we did. We spawned 2,000 virtual hypervisors in the 4 of VMs. That is the amount of hypervisors that we have in the other data center. And on top of them, we run around 14,000 virtual machines in this graph, all connected to a similar OVN setup to what we were planning or were using in production already for this data center. And the tests were fine. Here in our metrics, we see when we spawn the new hypervisors, we do some tests, we destroy, recreate. The infrastructure was looking fine, so I said, okay, this is stable. We are gaining experience with the data center. Let's move and think how we migrate the main data center. And our idea was to do it in different stages. So the first goal was to make OVN and LinuxBridge coexist together. So we didn't want this option of let's do a big intervention one day, we take everything down, we bring it back with OVN, let's hope that it works. We say, okay, that is too risky for us. Let's see if we can make it coexist together in a stable way, and then we start to migrate things. And this is what we did. It was working. And then the moving of OVN, we did it in 2 steps. And the first one, we decided to do a cross-cell resize. You will see later more details about why. But in general, it was to align a bit of our roadmap for the data center. There is a big data center refurbishment going on that will change layout of racks, different things. This will be intrusive. So we decided to align part of that with this impact to users to also do the migration. And then later on, this happened in the first quarter. And later on, in parallel, we were also exploring how to do live migration from LinuxBridge to OVN without downtime to enroll all the capacity that is not going to be affected by this refinement. And this is what we did in Q3. All of this first iteration took us around 35% done. So the idea is that now that we are more confident with the tooling, more operational experience, the next iteration, if we are lucky, should take us to 100% of completion and just drop LinuxBridge. So now the idea is that we will focus on these different 3 main steps, and the first one will be Daniel that will talk about.
So the first part of it all is basically we have now the LinuxBridge setup, Neutron runs with LinuxBridge, nothing else. And the first step that we need to do, we need to create our control plane. So no workloads or so will be touched, only the control plane. So in our setup, we use a 3-node cluster for all of the databases. So we have the northbound database, the southbound database, and the north-D in 3 different VMs that then communicate with each other and form the main cluster. Then we have southbound relays in order for our hypervisors to connect to the southbound so that we can scale a bit better. So the first step, just to create your own cluster, is fine, like it's standalone, nothing happens, it will be there. The second step, we somehow need to get all of the data that is currently in Neutron also in OVN. So whenever we enable the OVN provider also in, or mechanism driver also in Neutron, we need to be able to, whenever a port deletion happens or port creation happens, that it will be affecting both LinuxBridge and OVN deployments so that we both know about it. Basically what we did is, there's this helper, the Neutron OVN DB sync util, that will synchronize all of the information that is in Neutron databases also to OVN. So all of the network, the subnets, the ports, security groups and whatnot, it will be all synchronized. And then also in the Neutron database, the OVN revision number, like a number to just keep track of the state in OVN, will be also updated, will be relevant later. And the third step is then to enable OVN as a mechanism driver in Neutron itself. And at that moment, the control plane would run with both OVN and LinuxBridge, although no hypervisor is connected at this stage. So the theory was quite nice and mostly it worked, but there were some surprises that we saw. One of the surprises that we had, the initial sync of our 15,000 ports or so that we had in one big provider network was basically taking 24 hours for running the sync utility. So instead of saying we do a quick intervention, this was no longer the case. So we basically ran this in the background, which had the slightly disadvantage of the OVN revision number that is being updated was conflicting with port deletions from our continuous probing of the cloud. So in our cloud we have per hour roughly 800 port creation and deletions, which then as soon as a port was deleted after the sync utility was started, it would conflict as soon as the port would be updated in OVN and the revision number would be updated in the Neutron database because of a foreign key index. So this was not the nicest part. But okay, this runs mostly in the background, so no users were affected. But for the second part, when we enabled OVN, we actually scheduled an intervention to tell the user all about it. And we did not factor in an increase of 8 to 10 times of memory consumption. So in our setup with the LinuxBridge, we have quite a lot of RPC workers in order whenever all of the LinuxBridge agents restart to be able to cope with all of the amount of requests that come to the Neutron servers. So in our case, we just reduced them to maybe a third, and we ended up with a 2.5 times increase of memory still, because the RPC worker would also start the OVN connection. And a second part that was also not so clear in our smaller proof of concepts, we did not see this, that Neutron at the startup will go with OVN through all of the ports and check the status of the port and notify the database to say which state the port is in, if the port is up or the port is down. But it also focuses on all ports, also the LinuxBridge ports. So in our monitoring, all of a sudden, as we started the first Neutron server, we got an increase that basically half of our cloud should be down, as you could see, the port down status, which was only cosmetic because they all still had connectivity, but we were quite worried. But we patched the Neutron in the end, or the OVN driver in this case, to ignore the LinuxBridge ports locally. I think there is no ticket up to Neutron at the moment because our version is too old, but maybe this is something that we have to work together with the Neutron people in order to make sure that only the OVN ports will be looked after for the port status. And a second point is there is the OVN hash ring that is being used by Neutron for all of the API nodes to distribute the ports between different Neutron servers. We were going slow, so we only started one Neutron server that was going through all of the ports. As soon as we started multiple servers, the load was distributed and actually it was going faster. So now we have the control plane running. So let's focus on the next part, the cross-cell reslices.
So as Luis already mentioned, our data center has an ongoing refurbishment. So some of our pods had to be moved, which led to decommissioning of some of our hypervisors. These were 7-year-old Intel hypervisors, and the replacement hardware that we got for them was very new AMD, which obviously meant that we couldn't live migrate from the 7-year-old Intel hypervisors to the AMD, let it be for because of the CPU model or the CPU flags, which just did not match. We took this as an opportunity to consolidate some of our cells, which we had for historical reasons. And so we introduced the new AMD hypervisors as the M4 flavors to users. And because we already had the other AMD hypervisors there as M4, and all Intel were M2. We showed, we let the users use the M4 flavors, and the plan was that after we do both of the both stages that we are describing here, all M4 flavors, all M4 flavor hypervisors will be in OVN, while our M2 will be running LinuxBridge. We let the users do the code migrations themselves, but after a while we just forced them. So what we did not expect is the complexity of the cross-cell code migrations themselves. Because under the hood, it is the concept of shelving and unshelving. So it happens in 5 steps. The source hypervisor creates a snapshot from the base and the differential, uploads it to Glance, and then the target hypervisor downloads the snapshot and the base image to calculate with QEMU the differential, so everything can go back to normal on the source hypervisor. The problem is we measured this for our biggest VMs, which we were willing to migrate, which had 160 gigabyte disks. That this can take up to 4 hours, which was a problem because we had RPC timeouts, which were per step only set to half an hour, so we had to adjust them. We noticed that that executing fstream before the migration could have significant speed up, so we recommended it to all users. And now I will pass the mic to, virtual mic to Luis, who will describe some of the issues that we had in this part of the campaign.
So basically, during this first stage, the issues we hit are not necessarily connected with OVN or LinuxBridge that much, more about the concept of the cross-cell resize. We have the situations where we have to recover images of virtual machines that were deleted, so we have to do a bit of recovering of images from the cache, from the database, etc. So a bit of massaging the DBs, nothing super exciting. The only thing that was a bit more connected to OVN or LinuxBridge is the second point, that in some cases when there were some failures, it could happen that information about the port bindings in the database will be lost. So we have to populate the database with the port bindings, the information. Again, something that once you notice is not a big deal. It didn't happen often, but it's something we faced. We also saw, I don't know if at the beginning was because of the lot of new machines being added, some race conditions somewhere, that some hypervisors will lose their membership to the network segment. As I mentioned at the beginning, it's a highly segmented network. Again, something that we clean up, we don't see that often now, something happened. The fourth one was a bit more annoying. We discovered after the cross-cell migration that the information about the BTPM that the machines use, like Windows 11 and is stored in Barbican, will be removed for some reason that we're still investigating. We were lucky because this is a soft deletion, so we were able to recover all of these secrets, but something we are trying to understand a bit better, and once we have more information, very likely we will open back report upstream to see how we can fix this. And the last one was slightly similar with the information about the key pairs that you configure your virtual machines with. And in this case, yeah, it was missing on some part of the tables in the database, in particular the ones that are used to populate the virtual machine metadata. And in this case, the issue was reported upstream. We proposed a few things about how it can be solved, but so far it's still open, but still you can take a look and it's being tracked. And basically with this first phase, we finished with let's say the cold approach to migrate to OVN, and the next one was to live migrations. Danny will tell you a bit more about.
So yeah, we have quite a lot of users that obviously did not want to have 4 hours of downtime for their VMs. So one of the things that we initially also started was to investigate whether we can do live migrations. So the good thing is we have everything in one big provider network. So the idea is the VM just puts its traffic out of the network interface of the hypervisor and nothing will be handled. So it should be doable, right? So we did some initial testing. So you see on the left we have the LinuxBridge hypervisor, and we did one live migration. The VM is attached to the BRQ, so the typical LinuxBridge naming, and we live migrate over to OVN, and the VM will be somehow on BRQ01, but in OVS instead of in LinuxBridge. So, okay, obviously you don't have the network connectivity, but if you have an Open vSwitch bridge, you can just create another patch port in our setup and we would be fine, right? So next thing, do another live migration, and apparently now we are at beer, so the network name changes. So it was first a bit surprising, but then we thought, okay, if we already have this intermediate steps, and okay, if we already move, so maybe security groups might be applied in BRIN, but not on BRQ, because OVN controller only configures one of them. So let's make it a bit proper and investigate whether we can just fix the bridge name on the first live migration. Another thing that I just mentioned, I forget to mention, was the port status was being down. So OVN controller was similar to the concept before, like the information in the Neutron database said this port is not up, even though it was up, because OVN controller did not know about it. So to go a bit into the details of technically how live migration works, at the first stage, Nova will, like conceptually for the networking part, Nova will ask Neutron, or with the information that is cached in Nova, figure out the network information for the VM. And as a second step, this port information will also have the VAF type, which is at the stage still a bridge, because we're still running on the source hypervisor. And then Nova calculates the bridge name based on that, so BRQ with the UUID. And after the VM is live migrated, the port information will be updated. So now it's the VAF type would be OVS, and the Nova cache will also be updated, and it knows that it's OVS. So this is why at the first stage we would run to the wrong bridge, and then in the second live migration we have the right bridge name, because then Nova will use the BRIN that is using. So the simple idea was, okay, can we just do it on our setup if we just overwrite it in the code? And it really is as simple as some code changes, like if our flag is being set, we set the bridge name to have the OVS bridge. And with this, we could live migrate to the right bridge. The only thing that we could not fix was that the port status is being down, so the whole live migration campaign that we did was basically, instead of one live migration, we were doing two. But all of the experiences, I think Kuba will tell you now more about.
Yeah, so here I want to describe some of the issues that we had with the live migrations, and also there are some general issues that we had in both stages of the campaign. First, we did the live migration campaign during the second part of the year, and LHC was already running, the Large Hadron Collider. So we did not want to bother users like, hey, we need you to cold migrate your machine, and we would have to like maybe take the beam down, which is expensive and annoying. So we wanted to be transparent, but Windows 11 exists. Its VTPM is not live migratable yet, even in the current releases, and we are running on Yoga, so not like there it's not even possible. So we had to inform the users and cold migrate them. Sometimes we also had issues with some odd connectivity drops, so we would migrate a VM and it was not pingable. Sometimes it was not pingable only from some parts of our network rather than everywhere, but oddly enough the second live migration always fixed it, so maybe there was some issue, but we haven't investigated it further due to time constraints. But the more of the general issues which applied for both of the stages were that we switched from like a central DHCP service to the OVN DHCP, and as that one doesn't support privacy extensions and opaque identifiers, we had to change the network config so that there will not be IPv6 connectivity loss. So takeaways. In summary, we verified that running LinuxBridge and OVN side by side works, and it is actually the preferred option, because taking the whole data center down for a big intervention and bringing it back up had so many risks compared to this approach that we chose that one. We were able to even make some of the migrations transparent and live migrate, so that also works. But we know that cold migrations are the safer option, because you don't have to do all the changes, but you need to be able to afford them, and you need to be able to turn the VMs down for users, and it was not possible for us for most of the year. challenges ahead. We are only around 1/3 way down, so we will proceed with in next year with both cold migrations, because we will have to continue with the refurbishment. We will have some new hardware and moving around, and also live migrations in Intel hypervisors which are under warranty. We also need to get more used to the day-to-day operations with OVN, because we already found some issues with anyway. And we are trying to maintain a good community of operators. There's an Etherpad where we organize somewhat regular meetups of operators that do the migration to OVN. So I will thank you for your attention. If you're interested in this topic, we have a tag blog where we documented all that we have done in way more detail in a four series blog post. So thank you. I will not take you.
Are there any questions?
If I understood right, a long ago you went from LinuxBridge to a bit of OVS and then OVN.
So,
what would your advice to operators running OVS would be?
So we did not even deploy OVS with any OVS agent. The second live migration that you saw was already going to OVN, but since on the hypervisor there's an Open vSwitch running, this one we could manually do operations on, which obviously is not the preferred way for dispatch port. So I don't have any recommendations for the OVS part, because we actually don't know any of those agents.
Fair enough.
I think I heard you say that when you were running LinuxBridge, you were using external DHCP, like probably Neutron DHCP, is that right? So and then you switched to OVN DHCP.
In the past, with LinuxBridge, we would use rely on in our infrastructure. There is a central DHCP service managed by our data network team, and in the past we used to rely on that. Now moving to OVN, we benefit from the DHCP or the DHCP functionality of OVN. The main drawback of the central instance of DHCP that our network team provides is that it refreshes every 2 minutes, meaning that we always have this time some hacks here and there when we spawn VMs to wait for these 2 minutes for DHCP to be refreshed. In the case of OVN, it's immediate, so for us it's an advantage to leverage that.
So now everything is in OVN.
Yeah. Also, it comes with, in terms of all these issues that you find from time to time. At the beginning, when we started adopting it, we didn't realize that the way we were configuring Neutron, it was also resolving DNS automatically. Because in general, we rely on the DNS of the site, and in this case, at the beginning, even OVN was taking care of DNS resolution. That is not what we wanted, and in that case, we disable it and we rely still on DNS from the site.
Thank you.
Question on the. It's interesting when you configure OVN and like LinuxBridge at the same time, or have both of them populated. Did you ever try just in a single node just to pull out the one network stack and like restart something and get everything up with OVN on like the same node without any migrations?
So I think Jim Denton had a blog post about this for going from OVS to OVN, and it seemed like a very, let's say, dangerous part for 1500 hypervisors at the same time. It was a test deployment for him in the blog post, I think 3 nodes or 6 nodes or something like this, to test the whole with Ansible script, but we never tested anything in this regard.
I just wonder if you could do node by node this, like that. You don't have to do the whole, everything at once, but if you could do it just node by node.
Like in theory, I would say it might be possible to do it if you somehow are able to get the tab device from the LinuxBridge to the internal bridge with OVN controller running, but I have no idea how Neutron would handle having 2 times the chassis reporting to it with also the segments. So I'm not sure, never tested, but might be an interesting scenario to test.
The operator meetups you mentioned, are they public or just CERN internal?
They were public. We were reaching out over the mailing list mostly, and at the beginning over Zoom, but later on over the Jitsi from the Open Infra.
Could you maybe show the link to the Etherpad again?
Yeah.
Yeah. Otherwise, if you go to the tech blog, we have the Etherpad link there as well.
And also I think we will have the possibility of sharing the slides with the foundation, and they will be somewhere.
Yeah.
So let's see if we're lucky, because we realize that putting clickable links in this thing is useless.
If you want to.
But if you go through the main list, you search from LinuxBridge something in the recent months, there have been some calls for it. Yes, good.
How are you finding the network performance now that you are on OVN?
In, I would say, 99% of the cases, awesome. There is a few cases of intense use that we are starting to notice packet drops in the receiving way. So very likely we have to investigate more, but very likely maybe with OBS not coping with those particular loads. So we'll start to maybe at some point evaluate other alternatives like the PKPK and all these things. But in general, the demands are reasonable, so I would say yeah, most of it works fine. There's only a few services here and there that we notice this change of behavior since we moved to OVN.
Thank you.
Yep.
I see on the Etherpad you mentioned VLANs and Genef as segmentation. I assume you moved from VLANs to Genef segmentation, which I believe is only an OVN feature. Or how do you handle that?
So I think this was more from some operators that were also present in the talk, because it's like a lot of different people from all over the world. We did not have any VLANs so far. We just now, since we moved to OVN, we have the Geneve tunnels, but they are basically without any load, because we still have the provider network that just forwards it out to the physical interface.
The setup is the same. Because I think we are running out of time. I think we are already in the slot of the next speaker.
I think that it starts in 3 minutes, but
Yeah, still.
You can stop us. Well, last one.
Is your tech blog detailed enough for someone else to recreate what you have done on a smaller scale?
I would say it's detailed enough to get an idea of the main moving pieces to the level of recreating. That is a big work because we cannot explain every single thing. But the general idea of what we did, yes. Then you need a little bit of knowledge of Neutron or OpenStack to know where to put it.
The patches are all that we are using are also linked in the tech blog.
yeah, we will share the slides at some point when we go.
I'm not sure how to turn this, but yeah,
There will be somewhere.
Hey, I just wanted to come and say hi. Eric McCormick. I was on radio hours.
Oh yeah,
Talking about this stuff.
thanks.
I saw the talk pop up and I was like, hey, this stuff's